Okay, today in class we're going to do this AP Calculus problem from the FRQ. It happened in 2004. This one it talks about, right, because look what we've been talking about. We've been talking about this type of thing, right? This is an integral defined from a lower bound to a variable. Okay, so from -3 to x of f of t. Okay, where of course this is the graph of f. These are your values that we're going to use from f. Okay, so g of x is the area under the curve from -3 to something of this function. Okay, so that's what we're asked about, which is why we're doing it now when we have our derivatives of integrals and limits of integration and stuff like that. Okay, so part A says find g of 0. Okay, so we're simply going to replace x with 0 in both of our cases and see what we can do. Okay, so g of 0 is equal to the integral from -3 to 0 of f of t dt. Okay, so you should know that this means to find the area under the curve, because that's what an integral is asking you to do. Under, that's some awful spelling this morning. Under the curve. From -3 to 0. Okay, so that is what g of 0 is asking us to find, the area under the curve of our graph from -3 to 0. So let's come over here and look at what that is. So here's our -3 value, so you draw your vertical line. And here's your 0. So what type of a shape do we have here? It looks like we have a trapezoid. So you can use the trapezoid formula if you remember it. If not, we can break this into a triangle and a rectangle if those are more familiar to you. Okay, so if those are more familiar, this would be an area of 3 because it's 3 units wide and 1 unit tall. And this is a triangle with a height of 1 and a base of 3, which I believe is 1.5. Okay, so if you use the trapezoid formula, you would get a similar answer. The area under the curve is 4.5 units, and that's just what it wants. Okay, 4.5 is your answer for the area under the curve from -3 to 0. Okay, maybe you did use a trapezoid. That would be 1/2. A height of 3 plus a height of, height of 2. Let me go back. It has a height of 2, right? This is the height plus this is the height times the distance between your bases, which is 3. Okay, which is also, let's see, 3 times 3 is 9. 9 over 2, 4.5. Okay, so if you break it into a rectangle and a triangle, you get the same area as if you just did a trapezoid. Okay, which should work out every single time. So whatever you remember, do that. Okay, g prime at 0. So now we're going to use the second part of the fundamental theorem of calculus, which says that if we take the derivative of our integral, that's the same as plugging in, what was our limit of integration up here? X. So we're going to put x in for the t value. Okay, so g prime of x equals f of x times the derivative of x. Right, the derivative of x is 1. So the derivative of our integral, g prime of x, is given to us for this problem simply by the y values of our graph. Right, that's what f of x stands for, the y values from your graph. Okay, so for this whole entire problem, we can find g prime simply by looking at the y values for your graph. That's what f of x means. So if we're asked for g prime at 0, that means we're simply looking for f of 0. So let's come back to our graph. That's a line. Back to our graph. What is the y value when x is 0?
1.
The y value is 1. So g prime of 0 equals 1. Okay, so we have 4.5 for g of 0, and we have 1 for g prime of 0. Okay, let's look at the B question. Find all values of x and the open interval from -5 to 4 at which g attains a relative maximum. Where g attains relative maximum. Remember, g is given to you by this integral function here. So we want to know something about g by using the graph of f, okay, which is why these questions are fairly difficult, because you have to use something that we don't have to look at. Okay, so you should know that g attains a maximum or min, a max or a min, when g prime of x equals 0. Right? If the slope of our tangent line to our graph of g is 0, then you have a relative max or a min. Okay, it's going to be a max, of course, once we do a sign analysis and the changes from positive to negative, right? So we have slopes going up, and then we have slopes coming down. So we're looking for a sign change of positive to negative once we find the zeros of your function. Okay? So we know that g prime is equal to f of x, right? G prime of x is equal to f of x. So we're going to look at our graph and see all the places on your graph where y is 0, right? That's all of our x-intercepts. So let's come up here and look for our x-intercepts of your graph. Oh, I see there's an x-intercept here at -4. There's another x-intercept at +1. And there's another x-intercept at +3. Okay, so we're going to do a sign analysis with our three values. -4 is a 0, +1 is a 0, and +3 is a 0. Okay, remember, we're looking at slopes. We're looking at slopes of this. Actually, no, we're looking at whether it's above or below the x-axis. So to the left of -4 is your graph above or below the x-axis? It's below, so we have a negative value to the left of -4. Okay, what about between -4 and 1? Where is your graph? It's above the x-axis, so we're positive in between here. What about between 1 and 3? Also above the x-axis. And to the right of 3, our graph is below the x-axis. Okay, so remember, we're just looking at the positivity of our f graph, right? Everything here is coming from f. So when f is above the x-axis, we have a positive slope of g prime. And when it's below the x-axis, we have a negative slope of g prime. Okay, so our max, we're looking for a positive to negative change. And looking at our analysis, that occurs at +3. So let's see, g has a relative, we'll call it a relative max at x equals 3. Okay, that's your answer, right? You'll get 1 point for the answer. And now the justification, because g prime changes from positive to negative. Sorry, that handwriting is kind of sloppy in here. My writing utensil is not doing well. So g has a relative max at x equals 3, right? That is your answer to the question, because g prime changes from positive to negative. Okay, that's the justification part. You get 1 point for your answer of 3, and you get 1 point for your justifying saying something about g prime. Okay, so that's your calculus understanding. Okay, part C, find the absolute minimum value of g on the closed interval. Okay, so remember, minimum values we are trying to figure out either at the endpoints. Okay, so we have to check our endpoints for minimum or maximum values. This is the extreme value theorem, I believe. We check our endpoints for their y values, and we also check where g prime might be a negative, right, as a min, not g prime, but g. We want to find where g has a min, or is undefined. Okay, so these are the points that we're going to check. We need to check the endpoints. So we have an endpoint value of negative 5, and we have an endpoint value of positive 4. Okay, so looking at our minimums, right back over here, we kind of did our sign analysis already. And if we had a maximum value at 3, because it changed from positive to negative, we have a minimum value here at negative 4, because our signs changed from negative to positive. So 4 is going to be a relative min, where 3 is going to be a relative max. Okay, so we also have to check for negative 4 over here. Okay? So remember, we're looking at the g function, so we need to evaluate g of negative 5. G of negative 5, okay? And how in the world do we do that? Well, it tells us at the beginning how to evaluate g, doesn't it? So g of negative 5 is the integral from negative 3 to negative 5 of your function, right? Negative 3 to negative 5. Now, notice that the lower limit is greater than the upper limit, okay? Which shouldn't be a problem for calculus students, because we know that we can flip this around and just make the area negative, right? So this is the same as the negative of the area from negative 5 to negative 3. Okay, so don't be too concerned that the lower limit is greater than the upper limit. Okay, just make the area negative. So remember, this is the area under the curve. So let's look from negative 5 to 3. So from negative 5 to negative 4, what do we have? Looks like an area of a triangle with a base of 1 and a height of negative 2. So this has an area of negative 1. And from this, has an area of positive 1. Oh, negative 1 plus positive 1 is 0. Okay, so g of negative 5 is 0. Okay, we're going to do a similar thing for negative 4 and positive 4. We're going to replace our upper limit of integration and figure out what the area under the curve is for both of these. Okay, so this is what I got for these other ones. And when I plugged in negative 4, I got negative 1 as my area. And when I plugged in positive 4, I got something positive, right? So because we're looking for a minimum value, we're going to find the minimum value at negative 1. Okay, because that's just, we have a 0, we have negative 1, and we have something positive. So negative 1 is clearly the smallest value on our closed interval. Okay, so the last one is part D. Find all the values where we have a point of inflection. Okay, so we need to know that for a point of inflection, we're looking at the second derivative of x. Okay, and the second derivative of x is the first derivative of g. The second derivative of g is the first derivative of f. Okay, so we're just going to look at the slopes and figure out where our slopes are 0 or where our slopes are undefined. Okay, we need to check all these in a sign analysis. So let's come up here and figure out where our slopes are 0 or undefined. Okay, so we have an undefined value at negative 3. We have another undefined slope here because there's a cusp. We have a 0 at positive 1, and we have an undefined at positive 2. So negative 3, 0, 1, and 2 are the ones we're going to check, right, and do a sign analysis for. Negative 3, 0, 1, and 2. Okay, so we're looking for where do we have positives or negative slopes. So to the left of negative 3, we have positive slopes, right? The graph is going up. To the right between, we have the graph going down, so this is a negative slope. Between 0 and 1, the graph is also going down, so it's a negative slope. Between 0, 1, and 2, the graph is going up, positive slopes. And between after 2, the graph is going down, so negative slopes. So we're looking for points of inflection or changes. So here at negative 3, it changes from positive to negative. Here at positive 1, it changes from negative to positive. And here at positive 2, it changes from positive to negative. So G has points of inflection. sorry, I'm trying to write fast, at x equals -3, 1, and 2, because the signs of g prime change from positive to negative or from negative to positive. Okay, so either one of those two changes, we're going to have a point of inflection. Okay, so G would have 3 points of inflection. So this is how the AP test is going to question you about integrals, areas under the curve, and derivatives of integrals also. Okay, goodbye.